Hey everyone, and welcome to another video in the Python Fundamentals series. In this video, you'll be introduced to object-oriented programming in Python, which is one of the key and fundamental concepts that make up this programming language. You'll learn about what OOP is and how you can use classes and objects in any of your programs. With that said, let's get started. So, object-oriented programming. This may seem like an intimidating concept at this point, and in this video, you'll learn what exactly OOP is and how you can use it to improve your programs. To start off, what is object-oriented programming? In fact, what even is an object? Python is known as an object-oriented programming language, and it may come as a surprise that you have been using objects since the very first line you ever wrote in Python. There's a saying that everything in Python is an object, and people mean it when they say that. Everything in Python is an object. Earlier, we talked about the type function, which returns the class of the object passed in. So let's take a look at this cell. Here we have a string. This is an object. We pass that as the parameter into the type function, and we print out its return value, which gives us the output of class str. What this tells us is this string, this object, belongs to a class called str. And this true is an object which is an instance of the class called bool, and the same thing for this none as well as this dictionary data type here. All of the output above starts with the word class, which tells us what class the object belongs to. So, what is a class? When you think about it, in Python, there are many data types. We have strings, ints, floats, complex, booleans, lists, tuples, dictionaries, etc., and many more. But there is still a lack of support if we want to create data that represent real-world objects like cars, planes, books, things like that. But Python does allow us to create custom data types. You can think about a class as a blueprint for something, and it will define how that something will look like once constructed and how it will behave. Classes are often used to represent real-world objects, and they have properties and methods. Properties are usually just the variables that holds value inside the class, and methods are functions that belong to one class. In Python, to create a class, we use the class keyword. So we type class and then a space and then the name of the class, which is generally in upper camel case, which is where we capitalize the first letter of each word with no underscore between each word. After that, we see a pair of parentheses in which we can see this thing right here as well as comma and ... Don't worry about this, we'll talk about that in the next video when we talk about inheritance. And if we don't have any parent class, we actually don't even need this. And in here, in the body of the class, we can see 1, 2, 3, 4 indentation, and then the statements that belong to this class. So let's take a look at some examples of classes. Here we can see there's a class called myFirstClass, and in here we have a property and an attribute called var, which has the value of variable in myFirstClass. If I run this cell, you'll see nothing actually got outputted, because just like how the definition of a function doesn't run the function, when we create a class, no object is actually initiated. To construct an object, we can use the syntax object name is equal to class name with a pair of parentheses afterward. So what this does is it will create an object, an instance of this class, and assign it to this variable called object name. So here we can see my first object is equal to my first class and the pair of parentheses afterwards. So we will construct an instance of my first class and assign it to my first object. So if I print out this object and its type, we'll see some gibberish looking thing printed out right here. This is actually the memory address of my first object. And in the video after next, we will talk about how we can customize the representation, the output, when we print out objects. And we can see when we print out its type, my first class is printed out. When we access the attribute of an object, we can use dot notation. So to access the property x of object, we can write object.x. So here we can see my first object dot var is going to give us the string variable in my first class. My first class.var though also give us this exact same thing. So why should we even bother creating objects if the class gives us the same thing? As a matter of fact, why should we even write classes if all it does is hold variables? That brings us back to the discussion about object-oriented programming. If we take a look at objects of the int class, for example, we can see each object holds different values in their different attributes. So let's take a look at this int here. We can see int1 holds the value of one number and int2 holds the value of another number. And if we print out its type for int1 and int2, we'll see class int is printed out for both cases. There is a property of integers in Python called real. So int1.real gives us one value while int2.real gives us another value. So that's really the power of object-oriented programming. So to do that, we can use the init method. Remember how we talked about we can write methods in classes, and there's a special one that all classes have, which is the underscore underscore init underscore underscore the init method. And this method is called whenever an object gets initiated for a class. If we don't explicitly define one in a class, then Python will give the function a default one when creating the object. So here's an example with a custom init method. So we can see here's a class called programmer. And in here, indented, we can see a method called init. And we create this method just like how we would create any function. We can see def and then underscore underscore init underscore underscore. And here it takes 3 parameters. Self is pointing towards the current instance of a class. We'll talk about that in half a minute. And basically this points towards the current instance of a class. And we also have 2 other parameters, the first of which is name, and the second one is favorite language. And in the body of this class, which is indented 4 spaces further than the first line of the method, we can see self.name is equal to name. This name is the one passed in during the constructing of the object. Self.name is the attribute, the property of that instance of the programmer class. And the same thing for favorite language, where favorite language is passed in and it's stored as an attribute of that object. Now let's talk about the self parameter. Self is a special parameter that points towards the current instance of a class, and using it we can access variables of that object which we're working with. We don't have to call it self, although I doubt you will ever see it called anything else. And when we construct an object, and when we call a method for an object, we don't pass in self during that process. So here we can see me is equal to an instance of the programmer class with name equaling future programmer and the favorite language being Python. We don't pass in self here because it's implicitly passed whenever we call a method of an object. So if I run this cell, of course I have to first define the programmer class up here. And then if I run the cell, you'll see name is equal to future programmer. So me.name now holds the value of future programmer. What happened during this line of code was this gets taken all the way up to right here. So future programmer is going to be assigned to the variable name. So self.name, the attribute name of me is going to be future programmer. And favlang is going to be Python. So the favlang property of that object me is going to be Python. And if we print it out, you'll see name is future programmer and favorite language is Python. The power of object-oriented programming is creating multiple objects of a class that holds different values. So let's make another object of the programmer class called Bob. And Bob has the name of Bob and their favorite language is Ruby. So let's take a look at what will get printed out. This time, name is equal to Bob and their favorite language is Ruby. So hopefully by now you can see the power of object-oriented programming, of objects, of classes, where we can pass in custom values to each object of a class. And now let's talk about methods of a class. There are multiple types of methods that can be written in a class, although by far the most commonly used one, and we're going to focus on this one, is called the instance method, which, as the name suggests, is a method for a class instance known as an object. And you can think about a method like a function that belongs to an object. So let's take a look at this class right here. Class, the name is called dog, and we have an init method here that takes two parameters, name and breed, and they're stored inside the instance attributes called name and breed. We also have two other methods here, the first of which is the bark method. And notice here, even though we don't take any other parameters, we still have to pass in self for this instance method. And all it does is it print out bark 3 times. And we have another method called change name, which takes self as well as another parameter, new name. And this will change the name property of that instance that we're working with to whatever name is passed in during the method call. So let me define this class real quick. And in this cell, we can see we're constructing an object of the class dog, whose name is dog1 and whose breed is German Shepherd. And it's assigned to the variable dog1. If we print out dog1.name and dog1.breed, we can see dog1 and German Shepherd is printed out. When we call dog1.bark, notice how we don't pass in self again. So dog1.bark, we can see bark times 1, times 2, and times 3 printed out. Dog1.changeName is going to take one parameter from us, which is the new name, and after calling this method with this string as the argument, we can see new name for dog1 is now dog1.name. And just for fun, let's run this cell as well, where we can see dog2 is equal to another dog, which is a golden retriever, whose name is equal to another dog, and whose breed is golden retriever. And the same thing with bark method, which prints out bark times 1 and 2 and 3. And if we change dog 2's name to the second dog instead of another dog, we can see that's printed out right here. Maybe at this point you feel like classes and objects and object-oriented programming is something that you'll never ever use again. But trust me when I say, as you move along your programming career, object-oriented programming is going to be used all the time. You'll continue writing classes and creating objects of those classes, and it will just be really useful, and it will make a lot of your work easier. So to summarize what we talked about today, we talked about what is object-oriented programming, and we talked about classes, including how to make objects of a class and the init method, as well as instance methods. And that's it for an introduction to object-oriented programming in Python. If you enjoyed this video, make sure to like, share, comment, and subscribe down below. In the next video of this course, you'll learn about what inheritance is in Python's object-oriented programming. What's that? Well, why don't you click up here and find out. With that said, thank you very much for watching, and I'll see you over there.